Okay, so the question is prove that 2 cosecant 2x tan x is identical to secant square x. You can pick up the left hand side, that is the more complex side, and it can be simplified further easily. Cosecant is a reciprocal of sine
Fine.
2x and tan x. If I replace everything in terms of sine and cos, I know tan x can be written as sine x over cos x, and sine 2x is 2 sine x cos x using the double angle identity. Okay, sine x, 2 and 2 can be resolved. So you get 1 upon cos square x. And what is 1 upon cos square x?
Secant square x.
Secant square x. Yeah. Now in part B, hence find the exact value of 5 plus cosecant 2x tan x. So it has a command word hence, meaning you have to use the answer of the previous part.
Um,
Okay, let's do this step by step. Integration of 5 plus cosecant 2x tan x dx, integration of this expression from minus pi by 3 to plus pi by 3. Now if I have
plus,
to, G,
so will cosec 2x tan x be secant square x upon 2?
yes, exactly. So cosecant, the whole idea was that if uh, 2 cosecant 2x tan x is identical to secant square x, then cosecant 2x tan x is equal to secant square x upon 2. Integration of this is same as integration of secant square x upon 2. So I can replace this term with secant square x upon 2. That's the correct observation. So secant square x over 2 from negative pi by 3 to pi by 3. Okay, now let's integrate them. Integration of 5 is 5x. Integration of secant square x is 10x. And we have upon 2. Just apply the limit. Make sure your calculator is in radian mode. 5 pi upon 3. 10 pi upon 3 is root 3 upon 2 minus 5 pi by 3. 10 of minus pi by 3 is negative root 3 upon 2. So I'm getting 10 pi upon 3 plus root 3. Are you getting the same answer? Please confirm.
Yeah, so I was getting the same answer. My calculator is in radian mode, but for some reason it's giving me the answer in decimals instead of in terms of pi.
Which calculator version are you using?
FX991 ES.
Then it shouldn't be giving you. Are you sure it's in radian mode?
Yeah, so I just put it in radian mode.
Okay. And do you see that the button that says S to D? Can you press this button again and find that it gets converted into the search form?
Okay.
10 pi upon 3 is, are you getting 1.73205?
Yeah, so I am.
Just press this button and check if it, it can get converted into root 3.
I
When you
don't have
find,
the button on my calculator. I don't think so.
sure. So ideally my calculator is giving me 10 pi upon 3 as root 3.
Yeah, so is mine.
Is it giving now?
Yeah.
Okay. Okay. So just confirm, are you getting the same answer?
Yes.
Okay, good. Let's try another question. Try this one. So in this question, the first part says use the expansion of cos 3x minus x and cos 3x plus x to show that cos 2x minus cos 4x is identical to this. So we're going to start your working by cos 2x minus cos 4x is same as saying for cos 2x you can write cos 3x minus x, and for cos 4x you can write cos 3x plus x, and then use the expansion. What is cos A minus B? It was equal to cos A cos B
Upon
plus sin A sin B. So cos A cos B plus sin A sin B minus cos of A plus B was cos A cos B plus minus sin A sin B. Now you can just simplify this. Cos 3x cos x minus cos 3x cos x gets eliminated. Sin 3x sin x minus minus plus sin 3x sin x is 2 sin 3x sin x. That's it. Is that okay?
okay. Yeah, so that's fine.
Now in the second part, hence show that integration of sin 3x sin x dx is from 0 to pi by 4 is coming out to be 1 upon 4. Alright, so integration of sin 3x sin x is same as saying cos 2x minus cos 4x. I can easily replace sin 3x sin x dx in terms of cos, but I need to just take one thing into account, and that is that sin 3x sin x from 0 to pi by 4 is going to be equal to cos 2x minus cos 4x upon 2. Do you agree with this?
Yes, sir.
From 0 to pi by 4. You can take 1 upon 2 common out and integrate cos 2x. Cos 2x integration is sin 2x upon 2. Cos 4x integration is sin 4x upon 4. And the limits are pi by 4 and 0. Sin 2x upon, sorry, first of all we are going to plug in the limits. Okay. So you are going to get 1 upon 2 when you plug in pi by 4 in sin 2x over 2, and 0 from here, 0, 0, and the final answer is 1 upon 4. And that is what we were asked to show, that the result comes out to be equal to 1 upon 4.
Okay.
Now let's discuss integration of fractions. Integration of fractions says that if you have a function in the denominator whose differentiation is present in the numerator, then the integration of such function is nothing but ln of the denominator, that is ln of the function, plus c, where f is a function of x. This can be extended to if you have a function, if you have an expression in which there's a constant term being multiplied by the differentiation of the denominator. So you can just pull out this constant outside the integral sign, and then you are going to get the same form. Once you have the same form, you can integrate it as per the rule. So whenever we have differentiation of the function in the denominator present in the numerator, the integration is ln of the denominator function plus c. So we can discuss some examples. If you want to copy this down, you can as well. Now, integration of 2x upon x squared plus 3. What is the differentiation of x squared plus 3?
2x.
Is the differentiation of the denominator function present in the numerator?
Yeah.
So the integration, so this integration expression confirms to this form 1, and the integration is going to be ln of the denominator, which is ln x squared plus 3 plus c. Make sense?
Yes.
Okay. Try to do the next one. So for the second part, integration of tan 3x, I can replace tan 3x with sine 3x upon cos 3x. Now, if I ask you what is the differentiation of cos 3x, what would you say?
Minus sine 3x.
Differentiation of cos 3x is minus sine 3x into 3, which means minus 3. If minus 3 is over here present, then it conforms to the differentiation of cos 3x, right?
Yes.
So if minus 3, if you're multiplying minus 3 on your own over here, what you should do is you should also divide the expression integral by minus 3 outside the integration sign. Now this confirms to the differentiation of cos 3x, hence the integration is going to be ln of the denominator, that is cos 3x plus c. Is that fine?
Yes.
Okay. Let's see the next one. Integration of 3x squared plus 5x upon 2x cubed plus 5x squared. So again, it's a fraction given to you. What is the differentiation of the denominator? What is the
Sorry,
differentiation?
so I was muted. It's x squared plus 5x.
No, the differentiation of the denominator. Denominator is 2x cubed plus 5x squared. So what is going to be the differentiation?
X squared plus 5x.
Differentiation is going to be 6x squared plus
Oh,
5x. Okay.
okay.
6x squared plus 10x, sorry, 6x squared, 2 times 3, 10, 6x squared plus 5 times 2, 10x. You sure you're okay with this, or do you want me to
Yes,
elaborate?
I just mixed with integration a bit.
All right. So, but in the numerator, I have been given 3x squared plus 5x. If I look at the differentiation, that comes out to be 6x squared plus 10x, but in the numerator I have been given 3x squared plus 5x. Is there a way to make the numerator equal to the differentiation of the denominator?
You have to multiply it by 2.
If I multiply by 2, I'm going to get the differentiation, derivative of the denominator. But then, before integral sign, I'll have to multiply by 1 upon 2 as well.
Yes.
Now, this conforms to the differentiation. So, as a final step, I'm going to write 1 upon 2 ln of the denominator function
Let's see.
plus c. Okay.
Okay.
Now try this one. This has limits and an exponential function. So we are asked to find the integration of 2e to the power of x over 1 plus e to the power of x dx. If I look now, first thing that you are going to identify is that it's a fraction form given to you. The differentiation of 1 plus e to the power of x is e to the power of x. So if I just check the numerator, I have been given 2e to the power of x. So to eliminate this, I can take 2 outside the integration sign. Then I'm going to get e to the power of x 1 plus e to the power of x from 0 to 1. Then you can integrate this by saying that the differentiation of the denominator is present in the numerator. So the integration of such function is going to be ln of the denominator. And since the limit is given, you can apply the limits 1, 0. So first of all, you're going to apply the limit 1. So you're going to get 2 ln 1 plus e to the power of 1 is e minus 2 ln e to the power of 0 is 1. So 1 plus 1 is going to be 2. So 2 ln 1 plus e minus 2 ln 2. If you take 2 common out, you get ln 1 plus e minus ln 2. And if you remember the rules of logs, if two logs are being subtracted having the same base, then you can express them as a single log by dividing 1 plus e by 2. That should be your answer. Okay, now we are going to study integration by substitution. Now, this can be considered as the reverse process of differentiation by the chain rule. So, I'm going to show you how this works. Usually, this method is used when a simple substitution can be applied that will transform a difficult integral into an easier integral. So right now this is a difficult integral for me, and if I substitute the substitution given, it can be converted into a easier integral and I can easily integrate that easier integral. Okay, the only thing that you should be careful is that the integral must be completely written in terms of the new variable. So if you see question number 1 that says use the substitution u equals to 2x plus 1 to find the integration of 4x square root of 2x plus 1 dx. If the question wants me to substitute 2x plus 1 with u, I'm going to replace this with u. But before integrating, I'll have to convert every x terms in u. So this entire integral must not have x in it. It must have only u. So to begin with, if u is equals to 2x plus 1, what is x going to be equal to? If I make x the subject from here, x, would you agree that x is going to be u minus 1 upon 2?
Good. Yes.
And you are going to derivate, since I need to replace dx as well, so I need to find du in terms of du with respect to dx, and that is 2x plus 1 की differentiation is going to be 2. So dx is basically du upon 2. Now I'm going to substitute 4x square root of 2x plus 1 dx. To substitute this, I know 2x plus 1 is going to be replaced with u, and x, what was x equals to? U minus 1 upon
Over
2.
two.
Square root of 2x plus 1, 2x plus 1 is just u, and dx is du upon 2. If you see, 2 times 2 is 4, 4 and 4 can be resolved. You are going to get u times u to the power of half, that is u to the power of 3 upon 2, minus u to the power of 1 upon 2 du integral. So you can see now that the entire integral is in terms of u only, nothing else. So I can integrate u with respect this I can integrate the expression in u with respect to u. So this is going to be simply u to the power of 5 upon 2 upon 5 upon 2 minus u to the power of 3 over 2 3 to the u to the power of 3 upon 2 over 3 over 2. There is no limits given, so plus a constant of integration. If you simplify this, you are going to get 2 u to the power of 5 upon 2 upon 5 minus 2 upon 3 u to the power of 3 upon 2 plus c. Now the original question was not in terms of u, it was in terms of x. So as our final step, we are going to convert u back into an expression in x. So 2 u was 2x plus 1, u was 2x plus 1 plus c. That is the integration of this function. So you see, we were asked to integrate this complex function, and they gave us a way to solve this. They wanted us to go for a substitution. In exam, usually the substitution is given to you. So you convert everything in terms of u so that you get a simpler expression that you can integrate easily. So I was able to integrate u to the power of 3 upon 2 minus u to the power of half easily. Once that is done and you have integrated it, as a final step, you're going to convert u back into the expression of x. So that's your final answer. Do you understand this?
Okay. Yes, sir.
Are there any questions or do you find it difficult? Let me know.
No, sir. I just need to copy it down for 1 second.
Sure. Okay, so this question says use the substitution x equals to 210u to find 8 integration of 8 upon x square plus 4. So we see a term in x square, so I can square this on both sides and I'm going to replace x square with that term. So if x is 210u, x square, for x square I can square it on both sides. I'm going to get 4 10 square u. Agreed?
Yes, sir.
Then if x is equals to 210u, I need to replace this dx with du. So I'll have to differentiate this. Dx by du is going to be, differentiation of 10u is going to be secant square u. Agreed?
Yes.
Now, you want to make dx the subject, so it is going to be 2 secant square u times du. Now, once we are done with this, I can come up to the integration part, integration of 8 upon x squared. So I can replace x squared with 4 tan square u plus 4. I can replace dx with 2 secant square u du. This is going to give me 16 secant square u du upon 4 tan square u plus 4. Now, what is the next step that comes to your mind?
Um,
Can you come up with an identity that is going to help you solve this denominator? If I take 4 common, what do I get? 10
tan
square u
square.
plus 1. And what is 10 square u plus 1 equal to?
Um, secant square.
Exactly, secant square u. That's the identity. Now you can simplify the terms. So you are going to be left with
Or
integration of 4 du. Once you have simplified it, what is the integration of 4 du equal to?
uh, 4u.
Very good. 4u plus c. Okay. That is the second last step. Now, as a last step, you see, the question was not in terms of u, it was in terms of x. So, is there a way to use this substitution and make u the subject?
Yes, we make it x over 2.
Would you agree? It is going to be tan inverse of u x upon 2 because u over here serves as an angle.
Yeah.
So, that's why to replace u, you are going to write tan inverse x upon 2 plus c. That is the answer.
Okay.
Let me know when you're done. So the question says use the substitution u equals to sine x to find the integration of sine squared 2x cos x dx. Okay, so the first step what you can do is if u is equal to sine x, then if I want to eliminate, if I want to replace sine squared 2x, sine squared 2x means sine 2x the whole thing square, and sine of 2x is simply 2 sine x cos x. So 2 sine square x cos square x. For sine square x, I can replace u square. U square is going to be equal to sine square x. But what about cos square x? If I use the identity sine square x plus cos square x is identical to 1, and if I know that this is u, then what is cos square x in terms of u? It's going to
1
be 1
minus.
minus u square. Okay, 1 minus u square. This should be 4 sine square cos square x. Okay, then to replace this dx, if u is equals to sine x, then the derivative of u with respect to x is going to be cos x, and dx is going to be du upon cos x. Okay, so now our integration is going to become, I'm doing the integration bit over here. We were asked to integrate sine squared 2x cos x dx. Sine squared 2x is equal to this 4u square times 1 minus u square. Cos x, what to do about cos x? I'm going to let cos x be right away, right now, as it is. If I replace dx, dx was du upon cos x. So cos x and cos x are eventually going to be cancelled out. So this brings us to 4u square minus 4u to the power of 4 integration of this expression with respect to du. The integration is going to be 4u cube upon 3 minus 4u to the power of 5 upon 5 plus c. Now I can replace u back with sin x. So 4 upon 3 sine cube x minus 4 sine to the power of sin x to the power of 5 upon 5 plus c. This should be the final answer. Make sense?
Yes, sir.
Okay, good. Now, one last question. This is the last question for today. The only difference between this question and the previous question is that there are limits involved. And whenever limits are involved, we will see these are the limits of x. We are going to convert the limits also in u. Okay, so if u is equals to x plus 1, and when x is 3, when the upper limit is 3, when u is 3, then when x is 3, u comes out to be 4. That's the upper limit. When u is 0, when x is 0, u comes out to be 1. That is the lower limit. The rest of the working is going to be same. If u is equal to x plus 1, du over dx is going to be 1. So du is equals to dx. And if I make x the subject from here, x is going to be equal to u minus 1. Now let's go over the integration of this expression. To replace x, I can simply write u minus 1. To replace square root of x plus 1, I can simply write square root of u. Integration, the limits are going to be from 1 and 4, and you are going to replace dx by du. That's it. Now you can simplify this. U minus 1 upon square root of u is u upon square root of u minus 1 upon square root of u. U upon square root of u is u to the power of 1 minus half, that is half, minus u to the power of negative half. If you integrate this, you get u to the power of 3 upon 2 divided by 3 upon 2 minus u to the power of 1 upon 2 upon 1 upon 2. Limits are 4 and 1. If I rewrite this, I'm going to get 2u to the power of 3 upon 2 upon 3 minus 2u to the power of 1 upon 2. Limits are 4 and 1. We are going to plug in the limits. When you
Oh,
plug
so
in
how
the,
do you get 2u?
how did I get 2u? Okay. So u to the power of half upon half. When we integrate u to the power of minus half, we add 1 to the power divided by the new power, so it is going to be u to the power
Yeah.
of half upon half, and this number divided by half is 2 times u to the power of half.
Okay.
Okay. Now, when you insert 4, 4 to the power of 3 upon 2 is 8. 8 times 2 is 16. So 16 upon 3 minus 4. When you insert 1, you get 2 upon 3 minus 2. 16 upon 3 minus 4 minus 2 upon 3 minus 2. I am getting final answer as 8 upon 3. This is the final answer.